So let's put together the roll and glide of the condyles with the actual lateral translation on the top of the tibial plateau. This is where it starts to get a little more confusing at times. So what I need to realize is that the femoral condyles are actually rolling back and gliding forward. But on the whole, the femur, as it bends, is going to slide backwards in space. So if I've got this whole thing happening, I imagine the tibial plateau is my hand and the femur on top of it. There's a roll and a glide that way. The glide is that way. So roll and glide. But at the same time as that is happening, the entire joint is shifting back on the bone of the tibia. So I have a roll and a glide within the joint, even though it's sliding back on the bone. And this brings up how the tibia is moving. So if we think about the tibia, remember we felt the tibial plateau, and we felt a little bit about how that angle changes as we bend the legs. But we didn't explicitly try to think about it and feel it. So if you're standing up straight, the top of your tibia is parallel to the ground. Now as I bend my legs, the top of the tibia is going to swing down and forward, right? So if you imagine the femur on top of a platform that's swinging down and forward, you start to see why the femur is actually going to move back on this surface, right? If it continued to swing down and forward, but the femur didn't slide, then this tibia would soon get in the way of the knee bending. However, because the knee joint can slide, because the femurs can slide on the tibia, it gives us more range of motion. So we still have the roll and the glide that direction, but all this is happening within the framework of a moving floor or surface. And that gets into why we're getting this lateral slide of the condyles. So the way that's easiest for me to image this is to imagine first the tibial plateau dropping down and forward. And then imagine the femurs resting on there, rolling and gliding as the floor drops out, right? So it's like someone were running in a movie or something. Someone were running up a building, like James Bond was running up a building, but the building was falling this way, right? So relative to the roof, James Bond is traveling up, but James isn't actually going anywhere because the roof is sliding. And then when you imagine he gets to the top and it's like an old shingled building, that the shingles start to slide off the roof. That would be like the opposition glide, right? So the roll would be like his legs running. The slide on the tibial plateau would be like the roof falling, but James is still climbing it, but not really going anywhere. And then the shingles start to fall off right at the top, and he's like shooting the shingles out, and that is the opposition glide, right? So he would be running, but his feet would be going back in the opposite direction he were running as the floor is falling out. So it's a very sort of complicated image, but see if you can start to picture that whole thing, that the condyles are rolling and gliding and moving backwards on the tibial plateau. So here we go. The condyles move back on the tibial plateau and forward. And they move back and forward, and they move back and forward, and then I have a roll and a glide as they move back, and a roll and a glide as they move forward. So they roll back, glide forward, and slide back, and they roll forward, glide back, and slide forward. This is where it gets a little bit too complicated for words. So try to see the imagery and feel it within the knee joint. So see if you can allow the femoral condyles to rest into the menisci and feel the menisci as vibrant and alive and cupping the condyles on, I'd say, about 70 to 80% of their width, and then they have an opening in the center, or that horseshoe shape we've looked at. So see if you can bring the image of the menisci in to this roll, slide, glide movement image. And now we're starting to get an accurate picture of the biomechanics of that joint. But there's more.
If you enjoyed this video, sign up for the InBody Space newsletter and share the link with a friend. You can also find original content on Facebook and Instagram.